Hello everyone and welcome to Dr. Nikita's Pharma Online and kindly like, share, subscribe my channel. So your basic properties of the colloids are the optical property which includes the Tyndall effect. Second, you have the kinetic property. These are due to the Brownian motion of the particles and it includes the diffusion, osmosis, sedimentation, and viscosity of the colloidal system. And third, you have the electrical property, which includes the potential on it. Basically, it is a zeta potential, and you have the electrophoresis and electroosmosis, coagulation or precipitation. Now, electrophoresis, movement of colloidal particle under the influence of electrical field, and electroosmosis is the movement of the dispersion media under the influence of electrical field. Third, you have the coagulation property or the precipitation. Now you know that colloidal particles are uniformly distributed throughout the system. But when the charge on the particle is changed, potential is changed, when you're adding electrolyte or any third substances in the system, it becomes the interactions are changing, and these particles which are uniformly distributed, they come together, they aggregate, and they form the clusters or they form the floccules, and they start settling down, which is called as the coagulation or the precipitation of the system. You see this beautiful image, that is the scattering of the sunlight. Okay, this effect you see during the sunrise or during the sunset, and you will see the light is not continuous. The light is in the form of the strip or light is in form of the band, and this is because of the scattering of the light by the particles. Okay, and this effect is called as the Tyndall effect, and you can use this property to determine molecular weight of your colloidal system. Okay, so you see here the light is in the beam form. Even this effect you can see when you open the room which is not cleaned. It is having so many dust particles. So when you open it, you will see again light is in the form of the beams, or the light is in form of the strip. So why it is happening? I tell you a simple experiment to do at home, which will help you to understand. Okay, you can take three transparent bottles, one filled with the salt solution, second you fill with the diluted milk. You take 2-3 spoonful of milk and add into that transparent plastic bottle or glass bottle, and third you add some flour which you use for cooking, maybe rice flour or the wheat flour you can take, and you add into that bottle and you focus a laser beam through it. So when you focus a laser beam through the first solution, you will not see any path, but second and third bottle will show you the path. This is because the solution is containing some particles which is scattering it, and it is giving the path of the light. So you can see in this diagram, first, where it is a solution, second is the colloidal system, and third is the suspension system. So in solution, the particles are basically in dissolved form, or they're very small and fine in size, so they do not scatter the light. That's why there is no path of the light. And second case, you see there are some particles which are scattered throughout the system. So when the light is falling on them, scattering of the light is taking place, and this scattering gives you the path of the light. In case of the suspension, the particle is, these are the big size. The light is getting scattered. It is in the form of the cone. Okay. So these three are the different patterns in which how the light is getting scattered through solution, colloids, and the suspension. So if you see the this Tyndall experiment, if you take a colloid, suppose this is a cuvette which you have taken, or the cell which you have taken. Okay. So suppose this is a cuvette which you have taken, and it contains the solution or the colloidal solution, and you pass the light through it, okay, and it is crossing the path length of the solution is 1 centimeter. So you have the intensity of the incident light. When it is passing through this solution, it has some particle which is light is falling on them and scattering in all direction, and at the another end again you are checking intensity of the light. You have an equation for this Tyndall effect, that is Hc by T is equal to 2Bc plus 1 upon m, where H is the constant for system and H is equal to 32 pi cube n square into dN by dC upon 3 lambda raised to 4 n, where your this n is the refractive index. Then you have this dN by dC is the change in the refraction or change in the refraction index, and you have this lambda as the wavelength, and you have n as the Avogadro number. So in this equation you have Hc by T equal to 2Bc plus 1 by m. H is the constant. The T is the turbidity of your solution. B is the interaction constant for your system. Now C is the concentration in gram of your solution which you have prepared, and M is the molecular weight. So from this equation, if you plot a graph of Hc by T against the concentration, so you have this equation as a line of equation, like Y is equal to mx plus c. Okay, so your this equation becomes similar to your equation like y is equal to mx plus c. So when you plot the graph of Hc upon T against the concentration, you get the straight line with the slope 2b and intercept 1 by m. So when you invert this intercept, make inverse of it, you get the molecular weight. So you can determine molecular weight of your colloidal system, and again you can determine whether the particle size is big or small for this system. Okay, so you have more scattering, that means you have the less intensity of the light at this second end, and it indicates that the particle size is big. And from this intercept 1 by m, when you take the inverse, you can calculate molecular weight of the system. Thank you for watching my video. Kindly like, share, subscribe my video, and keep watching